Hello, everyone. Thank you for coming back to workshop number 5 of the Polkadot Inc. Bootcamp. Unfortunately, our original 5th workshop had to be delayed, but don't worry, it will be taking place a week from now, next Thursday, at the end of the bootcamp, so you're not going to miss out. Today we have a really interesting workshop, part 1 of 2 of the Coin Fabric workshops. Today our workshop title is Hacking Ink, and it's all about security in ink contracts and best practices. So I'm sure you're all really looking forward to it.
Well, hi everyone. I'm Franco, Bregante, security auditor at CoinFabric since 2021. I'm here with Facundo, Lerena, a developer who worked on Scout as a static analyzer for Ink. Thank to you all for attending to this meeting. This presentation is named Hacking Ink. We want to share with you common security and functional issues, not only for Ink, because some of them are patterns you will be able to identify in other programming languages too. So let's go to the introduction. I will turn off my camera so that you can focus on the presentation. Not too fast. Don't go too fast. In order to make it more entertaining, not only for you, but also for us, we are going to build an application. It is an investment fund where users invest tokens and a manager decides how to make the most profit out of those tokens. We will go through all the functions that this application needs, one by one, and we'll be mentioning the bugs and the contract has in its first version, and we'll be fixing them. First of all, let's see the specs for this application. We have two main functions for the user, deposit and withdraw. The deposit function converts the deposited amount in native tokens to shares. Withdraw calculates the tokens sent to the user, or the tokens that we have to return to the users, based on the shares of the total value in the contract. The manager is in charge of investing the tokens in a strategy, and this role, the manager, should be able to change the strategy. Let's see the boilerplate for this contract. Here we declare the storage variables. We have a mapping name users for storing the shares for each user, a variable for the manager account ID, user total shares, which is a variable that tracks the sum of those shares, and there is also a variable for the manager fee. After that, we have a constructor which initializes those values. Let's see the first function. We have deposit, that is the first function that we are going to review, because it's a function that we need for the user to give us the money in order to manage it and invest it. Here we take the caller and transfer value as the user and the amount. We calculate the shares in a helper function named calculate shares. We're going to see the function in a moment. And that amount is added to the mapping and to the user's total shares variable. Let's review the calculate share function. Here, if there are no shares, this means no one has invested yet, it returns the same value as amount. The ratio is 1-to-1 between amount and the shares. If there are shares, then the formula is amount divided by strategy balance, and that multiplied by users' total shares. Strategy balance is the value in tokens of the fund. Here we delegate call to the strategy so that it calculates that value based on how tokens were invested. Because I don't know, if we have a strategy that is investing in 3 DeFi protocols, we need the strategy to tell us how to calculate the balance we have in those protocols, right? But here we have our first issue. This issue might lead this function to return 0 when the amount is a non-zero value. Let's see the following slide. Divide before multiply. That's the name of this issue, no? Suppose we have the following values for amount, strategy balance, and total shares. If you open your calculator, the result of calculating the shares will be 350 million, as you see there, with that 0.7 as an intermediary result for the division. However, here the contract operates on integer arithmetic, not on decimal arithmetic like the calculator. Then the result for the division will be 0, and the same for the product. Here you can see that any amount lower than the strategy balance will result in 0 shares. Instead, if we divide after the product, we will get the same result as with the calculator. So we have to change the order in this operation so that we can fix that issue. In the fixed version, let's see the next slide, the product goes first and then the division. You can see it in the match, right? In the match statement. And with that change in the code, we are fixing this issue. Now Facundo will continue reviewing the other functions. So please go ahead.
Yeah. We have the investing strategy function that, given the strategy hash to delegate our storage to, we call the function called activate on that contract. In this case, we get the selector bytes from activate on compile time. That's, I think it's 4 bytes for the selector. And we then execute that function with using our storage. This function has at least 3 big issues. The first one is authentication. We should check if the caller is the manager, else anyone could start investing without permission using any hash. Not really one of our strategies, but any contract that has this. This activate function. So we first need to check if the caller is the manager. We create this function called caller is manager and check that using self-env caller.
Facundo, I think you've muted yourself.
Oh, yeah. I was mute. Sorry.
For seconds. So if you can just go seconds back.
Yeah, I can go away from this part.
Thank
we need
you.
to create this self-caller is manager function to check if the caller of this function is the manager of the fund, and we create the strategy function to save in our storage the hash of the strategy to make it easier for the manager to get that hash every time they need to invest. So yeah, we can create this function that it's a lazy value that holds a hash that it's the strategy. We need to check if the caller is manager, and we need to unlock the old dependency and lock the new one. What does that mean? We have in Polkadot chains sometimes the hashes of contracts, the code of the contracts, I think, can be deleted. So we need to ask the chain to lock that hash and save that code until we release that need for that hash. In this case, we release the old hash and we lock the dependency from the new one. And we save that hash to our storage. The other issue, it's a known bug, I think it's fair to call it, that when delegating calls with Enc, we need to specify manual keys on, I think I can use the pen. Yeah, we need to check this kind of manual keys here, because when the compiler creates them, there are many ways that the compiler can create them, and almost every time they are different, and we want it to stay the same every time we have this contract. And when we delegate calls to our contracts, the keys on the instantiated version of the delegated code, it may not have the same auto key, it's called, that the compiler gave us. So it's fair to say that we really need to have these manual keys set every time we use mapping, lazy values, or vec, the Enc version of the vec type, the vector type. So I was trying to get the laser pointer, not this one. Not setting a manual key in these cases could lead to really big issues, like corrupting all the storage here, because the delayed contract does not know how to handle empty things if the auto key is different for the one the compiler defined for us here, and it's almost assured to be different in every case. So you can set a manual key and be safe. Also, investing strategy has the peculiarity to have the delayed call at the end of the function, almost as a return value. And for that, we need to specify that this is a tail call. Any mutation to packet types made by the delegatee will be flushed to storage in that moment. If we don't specify this flag, the storage state before the delayed call will be flushed to storage, because the last stack frame will be popped and our stack frame will be flushed to storage. In this case, you set the tail call, and it will handle the case for you to save that storage instead of the one it's here in the last line before returning. This is consequence of the thing we talked in the last slide, and another similar issue with how allow reentry flag works. This is the version for the investing strategy function fixed, and we can go to the next one. Withdrawal function. The spec of the function is to get the shares of the users, update the user information, update total shares, calculate the remove tokens, calculate the manager fee. If this contract needs more balance to pay out to to the user and fee, it gets more tokens. Then it transfers to the caller those tokens and transfers to the manager the fee that's needed, that's set on the contract. This function has a few problems. One is input validation. If we don't mind make checks about the amount that the user can withdraw with something like checking this, a malicious user could pass a really large amount and set the total shares to 0. Because if we don't have something like shares less than amount, the user can put like the max number amount can hold, and then this line, the last one that says user total shares check sub amount, can be 0, and it will set the total shares of the contract to 0 because we did not check if the user had those shares in this contract. And the other possible error we can have in a function like this is a front running, because if the admin could change the fee, they could front run the withdrawal transaction to take more. In this case, in our contract, no one can change the fee because it's defined when the constructor is called. But if we create a function that changed the fee, we need to account for that in the withdrawal function and let the user set a max value to pay to the manager, like an slippage in swaps, to avoid from running the transaction and letting the user with 0 with no tokens, because the fee is 100% of tokens. Also, in this case, we are dividing before multiplying, and this can have issues like Franco said at the start. This is the fixed version of withdrawal. And there are other issues or enhancements in this contract. We can create a time lock mechanism in switch strategy. So if the manager changes the investment strategy, every user can retrieve their money to avoid investing in a new strategy that they don't like or they don't want to invest in. The fee changing function, that's what I was talking about a few minutes ago. And we need a slippage parameter in other functions like withdrawal to prevent from running. Also, we can have better error handling almost in every function. And instead of using manual keys with an hex value, we can define an enum to make it easier to us and easier to read where are everything saved in the storage.
Also, Facu, excuse me one moment.
Yes.
The time lock mechanism in switch strategy is not only for investors to decide whether they want to stay in the fund when the new strategy is decided, because it can be just because of I don't agree with that strategy because investing in these protocols is not better. But also can be the situation where the manager implements a malicious strategy, where the strategy is, hey, transfer all the tokens to my account and buy. That also can happen. That's why that time lock mechanism is important, because users can prevent losing money because of those malicious strategies.
Yeah. So that are some issues or enhancements that we came up with this contract. And yeah, we work at Fabric, an R&D and security auditing company. And yeah, we have a few tools like Scout and Franco, and the audit team works in auditing almost a lot of chains and protocols. So it's
Yeah, we audited Substrate blockchains and also palettes for Substrate. As well as you worked on Scout, which is the static analyzer we mentioned at the beginning.
That works for Ink. Also works for Rust-based chains, but it started with Ink, and I think it's really cool. It works really. It's really useful for checking the things. A few of the issues that we came across here are detected by Scout. So yeah, it's really cool to have a hand to fix those before going to audit or releasing a project.
Also, you will have a workshop that will be presented by Facundo too. So
yeah, and Fede, yeah.
And Fede. Okay.
Yeah, then I think it's next week. Yeah.
You will learn how to use Scout and catch many of the bugs we already presented today. Well, if you have any questions, you can share them. The presentation code is in the repo we share there. I don't know, is it public now?
I think it's not, but I will say that it's public right now.
Okay, it's not public now, but shortly it will be published. So it's the same link, just copy that and it will be available in just a few minutes. There's a question. Oh, Rebecca, you're mute.
Sorry, we'll share the link in the recording as well, so anyone who's watching the recording can check the description for the GitHub link.
Okay.
But
we
yeah,
have a question that is, what's Europe? Oh, excuse me, Rebecca, I don't want to interrupt you.
I was going to say you can read from the question tab.
Yeah.
Okay. What's our opinion, thoughts on using AI to audit smart contracts? Well, AI is great. It can find some of the issues we already mentioned, but it's not a fit-all tool. I mean, many of the issues that Scout can find, for example, are not found by AI. Also, you have many false positives when using AI for back finding. And even if you combine those two tools, they are not able to find the more complex bugs that a contract or a program can have. so that you need always to audit the code with an audit firm. Those are great tools, not only for you, but also for us when we are working, but they are not enough. And you always need some expert in order to look for those bugs.
That makes sense. So does anyone else have any questions about security best practices on writing ink contracts or anything to do with coin fabric? Next Tuesday, we're going to have another workshop dedicated to Scout.
Yes.
So we'll hear more about that on Tuesday. But does anyone have questions about general security? Otherwise, we'll do either of you have any suggestions for some tasks that these guys can try after this session to sort of make sure they've understood? So maybe checking a contract or...
Yeah, in the repo, we have a branch that's called Hackable that has a lot of issues. Almost every issue that we talk about, it's there. Try to fix them and try to find some errors on the main branch that has like our fixed version. Try to find issues there that's almost I'm sure it has a lot of issues, and try to find them.
Very nice. So go to the hackable branch and try and find the bits that make it hackable. Love that. Okay, so I don't think we have any more questions about security, so we'll end this workshop here for today, and we'll see the Coin Fabric team again on Tuesday for Meet Scout, the session on using Scout as an assistant for writing secure smart contracts. So thank you everyone for joining us today. I just wanted to note a few people have been asking if they can send their homework descriptions privately, and that is absolutely fine. You can email me or you can DM me on Discord if you don't feel comfortable posting them publicly in Discord or online. So do DM me if you'd prefer to do that, because I'll remind you, in order to successfully graduate, you do need to complete a homework every week to make sure you're consolidating your learning and you know what was covered in this week's workshops. So do DM me if you have any questions about that. And otherwise, we'll end the session there for today. Thank you everyone for joining us again, and we'll see you all on Tuesday for workshop number 6.
Thank you for inviting Rebecca, and thank you all for joining